thought that when she
Okay,
hit,
we're ready.
that it was going to go.
Yeah.
Laura, you're good. Welcome to today's SEI Live. I'm Laura Champion, Managing Director at SEI. The discussion today is on performance-based design and its future in structural engineering. Today's host is SEI staff member, Standards, Jennifer Gutierrez. Jennifer is a professional engineer who graduated with a master's in engineering from Cornell University and a bachelor's of civil engineering from Virginia Tech. She began her career as a structural engineer with SOM in Chicago before eventually working for SEI since 2011. She currently manages the SEI Codes and Standards Division and is recognized authority on standards. The staff editor on SEI's recent performance-based design publications funded by the Charles Pankow Foundation. Jennifer will now introduce today's guests, Don Scott and Melissa Burton. Thank you for attending and be sure to engage in the live chat. Jennifer, go ahead.
All right. Thanks, Laura. Sorry about that. I am so excited for this discussion. But before we get started, I really wanted to introduce these guests to you so you know how fabulous they all are. So joining me for today's discussion are two luminaries of wind design, as well as experts in the topic of performance-based design, Melissa Burton and Don Scott. Melissa Burton is currently Arups consulting practice leader for Canada out of the Toronto office. Melissa's work focuses on the intersection of the built and natural environments. She started her career looking at how the wind climate affects the buildings we design and how the consequential reaction of the buildings affect the people that occupy them. Her technical expertise extends to beyond code approaches using advanced analytics and tools to quantify and reduce design risk from wind loading. Also joining me today is Don Scott, a senior principal with PCS Structural Solutions in Tacoma, Washington. With more than 38 years of experience in the design, evaluation, and rehabilitation of building structures. Don is the chair of the SEI Codes and Standards Executive Committee, chair of the ASC 7 Windload Subcommittee, a member of the ASC 7 Main Committee, and past chair of the NCSEA Wind Engineering Committee. Don is a past president of the board of directors of the Applied Technology Council, and SEI is very fortunate to have Don as a current member of the SEI Board of Governors. Both Don and Melissa contributed to the ASCE SEI Pre-Standard for Performance-Based Wind Design, an effort funded by Charles Pankow Foundation. Don led the effort to develop this document, available as a free download from SEI and Pankow Foundation, which publishes criteria and methodologies for designing tall buildings to be more resilient in wind events. So, with that very brief introduction, let's go ahead and get started. Okay, Don and Melissa, let's begin with an overview, a broad explanation of performance-based design in general. As we have noted in lots of our work together, this is the beginning of performance-based design for wind. Seismic design has included performance aspects for decades, as we've talked about so many times. So what are we talking about exactly? What is performance-based design? Would each of you like to share your perspective on performance-based design, what it means to you in your practice, as well as what it could mean for the profession? Let's start there, kind of at the basics, to frame our discussion for today. So, Melissa, would you like to start?
Thanks, Jennifer. So performance-based design to me, really means about being more thoughtful about how we approach the design of our buildings and actually really taking that design and challenging ourselves to push ourselves to new limits. And when I say limits, I don't mean unsafe limits. I mean not falling into old habits of using materials to simply stiffen up or heavy up our structures. So it really is about thinking more from a sustainable perspective in the way in which we design and a resilience perspective in the way in which we design. So as I'm sure a number of people in the audience will know, performance-based design for seismic has been around for many decades. This is a paradigm shift that we're about to undergo in the wind world. and the consideration of wind loading in the structures that we design historically has been done through a code approach, or perhaps through physical wind tunnel modeling, where you come back with new loads that you then integrate into your design. Performance-based design is going to take us a step further. So we are going to really be looking at all of the performances of all of the members that we design in our buildings, all of the columns, all of the elements, all of the connections, and really thinking about how the wind load interacts with the built environment and these buildings that we are building, and how we can design them better to be more resilient against, potentially even a climate that we see as changing.
That's a very good point. I hope to get into that a little bit more as we have the discussion about the changing climate. Don, what about you? What are your thoughts?
Certainly, and I appreciate Melissa's last statement. I think performance-based design really, we talk about it as a future thing. It's really taking us back to the basics. How is our building or our structure going to interact with the loads that are going to be pushed upon it? I do come from the West Coast of the US, so I have been doing performance-based seismic design, as we've mentioned, for decades. And so you really take that and allows you to provide a unique solution for your structure to the problem that your structure is going to see, and satisfy them with the engineering principles that you learned back in college. We're kind of taking you back to the days of what you learned back in college. And like I said, it helps you to better understand the response of your structure to the loading that you're going to see, and then design for that response and make sure that everything meets the engineering principles that you have. The one thing that really kind of started us on the wind PBD approach is a unique situation out for the West Coast, where if you do a performance-based design for a seismic, for a tall building, you get to the upper floors where wind controls of that design. And now all of a sudden you have this conflict of doing a stiffer for wind, and it's really actually causing the performance of your building to be worse for seismic. And so we want to integrate those two designs together. And so that's what was the impetus for it, but I see it as a lot more uses that we'll have, a lot more opportunities we'll have for buildings in the tall building world.
That's really interesting. I'm going to follow that thread a little bit more, Don,
Sure.
because we have talked about, up until this point, performance-based design really has been used to kind of creatively solve problems that that we kind of bumped into the code a little bit, specifically where you're talking about where you had the seismic design driving it, and then the wind in the end started almost feeding it more load because it was too stiff.
Yeah.
But we can look at that and say, well, back to Melissa's earlier point, are we just doing performance-based design really to alleviate some of those pinch points in the code, or is there an opportunity for us to use it, I would argue, more creatively, to not just get around the code, but really get the performance that you want out of the building? So why don't you talk about that a little bit? Where have you used it to really, work with the building that you have to get the desired outcomes that you're looking for?
No, great point, Jennifer, that it's not, and maybe I didn't say it properly. You're correct. We're not trying to just get around the code. We're trying to make sure that the building responds the way that you want the building to respond.
Mm-hmm.
And there's really been, in seismic world, I'm sorry to go back to that, but
well, that's where it's been. So
yeah, I can't pretend that it's not there. That there's been two uses for performance-based design: either to get around something in the code, or to provide better response for your buildings. And I think that's what we're all looking for, is we want our structures to respond better to the loads that we know they're going to see at some time during their life. And so we want to understand how they're going to react. And that's really what performance-based design allows us to do, is to understand how they're going to react and how they're going to perform, and make sure that that performance meets the needs of the owner or the use of the building. So
Go ahead, Melissa.
Yeah, I was just going to say I might pick up on that actually, Dawn, because I think it's there's something really interesting in there that I think is important maybe for the audience to hear, is that the way in which we actually tend to consider design from a code-based approach, or even if you've done physical model testing, is it's at a design point.
Yep.
And that design point doesn't represent the true story of what our buildings need to undergo over the entire life of their existence. So I define it more as a design space. Your life needs to resist a 25-year event. It needs, or sorry, your structure needs to resist 25-year, 50-year, 100-year, 200-year, a whole slew of different, whether it be hurricanes or winter storms that are going to come in and interact with your building. And when you're actually thinking about doing a performance-based design, it really gives you the opportunity to scan every moment in the life that this structure is going to reside and exist in the built environment. It forces us to take our heads out of consideration that potentially in some cases is actually under conservative in the way, or unconservative, sorry, in the way in which we design. I think, as engineers, we often tend to think that our codes are the conservative approach. And certainly when that comes to wind, that's not always true, especially as you start to go taller and taller and taller. And so this enables us to really, to Dawn's point, really assess, the performance across the whole life of the structure. And that's an exciting change, I think.
Yeah.
It is an exciting change. We just had a comment in the chat about that, Melissa. Would you respond to this notion that this person says, I would argue we don't understand the loads well enough to be able to assess the performance at all those points? What would you say?
Yeah. Yeah, I think there's certainly truth in that. That we need to also be really careful about how we are undertaking a performance-based design, because there's a lot of watch-its that come about as we move into this new world, and a lot of considerations that we also need to be thoughtful of. And understanding our loads across the whole life of the structure really requires a clear, defined understanding of the native climatology in which you are looking to build your structure, and the potential way that climate is going to change in years to come. But in addition to that, also the structure itself. So what is it? What are its modal characteristics? How much mass are you actually going to see in the built structure, not just in your assumed structural model? And the stiffness that you're actually going to see again in your built structure,
Right.
not in your assumed structural model. And so the marriage of these two pieces really kind of defines the loads in which we see in the buildings.
And just to say that the change in the structural properties that you're going to see over the life of your building, because your building properties don't stay the same. The structural properties of your building do not stay the same as over the life of the building as when they were originally built. So you have to take all of those things into account.
Let's go a little further on the pre-standard. Since we did kind of talk a little bit around that, there's a lot of questions in the chat about the pre-standard, mostly just about the availability of it. But I did want to share with you that as of last month, I learned that the document has been downloaded more than 5,000 times. So there is definite interest in it. That's a lot of downloads. What do you make of that? Why now? Like, why do we choose to do Win now? And where do you see the interest, and where do you see that going?
Well, I'll maybe start, Melissa, if that's okay. The 5,000 downloads is shocking, to tell you the truth. I was totally shocked when I heard that number. But it really shows that the interest that people have in really getting back to the basics of it, to understanding what the what is required. First of all, I'm sure they downloaded it just to find out what was required to do a performance-based wind design. And there's a lot of people out there comparing it to the seismic as we've done, but we can use it for other loading type, other loads other than seismic and wind. Those are the ones that we do for the lateral system, but we can do performance-based design for all of the different type of loading. And recently, Jennifer, of course, you edited the performance-based fire standard, or examples that were done. And so you can use them for all aspects of engineering. And I believe people truly are hungry for that as they look to in their business. And what it's going to do is performance-based design for every structure out there. No, it's not. The code handles a good majority of the structures that we have, but every one of us in our practice will come upon unique structures that have unique design requirements that we need to think about, that don't fit within the prescription of the code, that we need to think about what we're going to do to meet those unique design requirements. And that's what performance-based design allows us to do. And the pre-standard gives us, for wind, gives us the steps that we need to take and what we need to satisfy to do that. The one thing I think nobody's mentioned yet that we need to talk about is that every really performance-based design is peer reviewed. So you do need to work with your peer review team to make sure that the assumptions that you're making and the objectives that you're trying to get with your performance-based design meet what the industry standard is. So it's not like you're just going out and selecting them by yourself. You work with a qualified peer reviewer to make sure that they meet the needs of the design of what you're trying to do.
Jennifer, I just wanted to, I think so. I just wanted to pick up on the 5,000 downloads. I concur and echo Don. Astonishing, amazing, and I wonder, if part of this is stemming from the fact that we have had one of the most active hurricane seasons on record this year. My last check I haven't found where we've ended in the Greek alphabet, but we don't have another naming convention once we reach the end of that. And I think the pre-standard isn't just for tall buildings. There is also a really great section in the pre-standard that really talks about building envelope performance. And in a lot of these medium to large hurricane events, that is actually where we see some of our early failures, or our first failures, is through the MEP equipment on the rooftop, through the facade elements and the glazing. And I suspect that chapter in the document is being picked up and used in a whole different type of buildings beyond that, just where we're going to kind of push the structural performance. There's some great advice in that document about ways that we can actually improve the performance of our facades in these hurricane events.
And just adding to that a little bit, Melissa, I agree. Phenomenal chapter on the envelope, and I'll just remind Jennifer and I were sitting in the ICC code hearings a couple of years ago, and about a month after the document was published and available, and somebody referenced it in the ICC code hearings for the envelope procedure. Both Jennifer and I looked at each other and just went, wow. We were amazed that it had been downloaded, read, and was being used for testimony on the ICC thing for an envelope question on there. So it really is the envelope is extremely important for wind design, as anybody that's ever looked at a series of buildings after an event. Is the envelope that really we need to pay attention to.
Absolutely. You get breakages in your envelope and you get water inundation through your building, and big challenges.
Yeah.
There's a little bit of chatter in the chat about, I guess I would categorize these things as mechanics of how performance-based design actually works. So if we say, no longer look at ASC 7, what do you do? Or if we say, I want a little bit better performance on my building envelope and go to the owner and have the discussion, you know, speak to the notion that it's not a all or nothing. Speak to the notion of how you can strategically and purposefully use maybe higher performance for different aspects either of the building or of the hazard.
Yeah, so we actually debated this long and hard. You know, we had I don't know how many meetings where collectively Jennifer, Dawn, myself, and all of the other members of the production team for this document, we actually debated this quite long and hard about the utilization of this pre-standard in part or in pieces, and you know, given our understanding of you know, the performance requirements of the facade or the building envelope systems, we felt very strongly that this should be a document that you could come to learn from and adopt performance measures coming from solely the building envelope document without needing to go down the entire route of looking at the structural performance of the building. And there are, you know, a whole swath of different building types where the actual value of performance-based design or performance-based wind design really sits in either a structural assessment or a building envelope assessment or in the combination of the two. And yeah, I think you know, that's where we landed, is that you know, ideally you as the structural engineer can come to this document and, you know, can see that there would be value in adopting part of it in your building, and you can then take that as a value story to the owner. And Dawn, I'm not going to monopolize time right here, but we should probably also talk a little bit about some of the work that we're doing in ASC Group 3. Because I think that value story and those outcomes are going to be, you know, a story that we can talk about in, say, a year's time.
Yep. No,
But I let you respond to the question first.
Yeah, sure. Thanks, Melissa. Yeah, I'm going to take a little bit different approach. I totally agree with everything that Melissa said on there. The one thing I do in my practice, and this is, I'm going to go back to what I actually do in practice, meeting with the owners on facilities. As Jennifer knows so well, and Melissa knows so well, I do a lot of hospital work in my practice. And so I have owners who are very interested in their facility remaining open after a catastrophic event, and they want to have that assurance that they're there. And so we'll meet with them and talk to them about all these different aspects that we're talking about. And do you want to have that, you know, do you want to have the cladding stay on the building after a wind event, or do you want water infiltration, and how much should we pay attention to that? And those type of things, seismically, you know, or we also do it looking at it seismically, the same thing, more the lateral system there. And it's really an education process with our owners and our users about what we can do if we analyze and understand the building's reaction to loads, or how it's going to respond. The more that we can understand that, the better that we can predict how we can solve these problems of water infiltration or of losing mechanical equipment off the roofs and those type of things. Those are it's really the education part of the PBD with the clients that really bring around the success. And they get to pick and choose. As Melissa said in the WIN document, they get to pick and choose what they're willing to and what their budget can absorb. You know, that's really part of it, what their budget can absorb. Though I will tell you from firsthand, using these documents, it doesn't always cost more. Everybody assumes that performance-based design costs more for construction, and it doesn't. It can actually save you money in construction. Yes, it's gonna cost you more in the design aspect because you're gonna do a lot more higher end analysis of your structure, but it doesn't cost more in construction a lot of times.
You're shaking your head, Melissa.
I am shaking my head because I actually, I wholly, I agree with you, Don. I actually think more often than not, it saves money.
Yep.
And the reason is because you're making sensible choices about the levels of material you need to inject into the building in order to resist the loads that are imparted upon it from the environment.
Yeah.
And so as you are able to trim out that materiality, you inevitably save money.
Yeah.
Let's talk about that. Let's follow that a little bit more and talk about, again, the mechanics of how this might work, because you are all very familiar with it. Some of our listeners might not really understand what we mean when we say, take it to the owner, put the material where you want it. Don and I have recently been doing some sessions on performance-based design, and we basically start with the kind of the flow chart of the process. So how do you even begin the process? You look at your project goals, you look at your project, the performance you're looking for. So maybe the acceptance criteria is what we would call it in our documents. And you marry those up and you work towards the hazard that you're trying to achieve. So would you like to talk? We'll get to Melissa's point about ASC 7 performance based. We're going to get there eventually, but I just kind of want to paint this picture for our listeners so they understand really what we're talking about when we say, oh, well, you just pick this and then you pick that. Explain that a little bit.
Certainly. Well, unless Melissa, I'll start. I'll let Melissa respond later on. But yeah, it's a very simple flow chart that we've used and presented, and that's for performance-based design. It's not a long, involved one. It really only has about 4 steps. You meet with, first of all, you as the engineer, or the engineer and the architect together need to set and discuss what you want the performance of your building to be. So you're kind of choosing what you want to do. And what we call those is we're meeting performance objectives. That's the objective of our design, is to have a building that reacts like this and will do this in the large scale events. And so such as, for wind, whether we're going to have water intrusion, whether we're going to have loss of the mechanical unit on the roof, whether we're going to have, damage to the cladding system in some way, or the structure, and now let's look at the structural elements. Are we going to go into the yielding stage? Are we going to go nonlinear a little bit in the building? Seismic, we of course go nonlinear, and we define how much we go nonlinear. In the pre-standard, we've allowed a little bit of non-linearity, which is totally a new concept for wind. And so you do that with your design team, because it does take, consultation with all of the design team members to discuss those things. And then you meet with the owner and you write up what's called a basis of design. You sit with the owner and you say, do you agree with this or not? And most of the time it is Greek to them because it's engineering and they don't, but you try to explain it as best you can in layman's terms about what you're talking about. They get the water infiltration, they get they get those type of things. The nonlinearity things they don't understand at all, okay, most of the time. But you write up a basis of design, and then you analyze your building. Well, you meet with your peer review team to get that basis of design approved and make sure that everybody's on the same page. And usually when I say the peer review team, that includes the local jurisdiction.
Good.
So we're not leaving them out of the loop in any way. That includes them in that peer review team. And so then everybody agrees to what your objectives are. Then you go and analyze your building, and you usually use a lot of higher analysis, nonlinear type techniques that you would use to analyze your buildings with input from the wind time. For a wind PBD, you need wind time histories, basically. We all understand what seismic time histories are. We also need wind time histories to apply to this nonlinear model, and then analyze it, make sure you meet the criteria that's been Melissa defined in her chapter in the pre-standard, and then come back and does that meet your basis of design? If it doesn't, you got to make some adjustments to your building, and you work through that. And then you send everything to the peer review team to review it. And if they agree with it, your design is really done then, and move forward. I'll let Melissa go on from there.
Yeah.
Yeah, I was just going to say there's a couple other criteria that we have specified, aren't there?
Yep.
And that's deflection criteria,
Yep.
The occupant comfort criteria. So also, some of these objectives that you need to set right from the get-go. And I think, in language really that parallels the code, this is really, about setting in some way, the risk category that you're considering for your building and your reliability level.
Yeah.
So I think that, that's kind of the parallel language that we utilize in the ASC 7 approach. Although we don't have, hard, fast deflection criteria nor occupant comfort criteria in our codes at the moment. And so this is these are additional considerations that will come about as you're going through performance-based design. We also have a residual drift criteria, which I think is an important one to mention, because that one, you can really only assess when you are doing your nonlinear time history analysis.
And residual drift, people understand that is your permanent set that you have in the building after your event, and that's really what that means. You've hit your building, and you want to make sure that the elevators still work, those type of things. And so you're limited on that residual drift that you would have after the event.
So we have some comments from the viewers. This is basically a statement. Maybe you would probably agree with this. Sounds like performance-based design could cost less in construction, but maybe more for the design aspects of it, because you're going back maybe with a more fine-tooth comb. And I would add to that,
Absolutely.
When we talk about performance-based design, we often will say, I didn't coin this term, somebody else did, but you take the design process and you put it on its head. Yep. And you start with the end, and you kind of work towards that versus taking the code and just starting to apply loads and working through it that way. Really looking at what we want at the end for our performance and kind of working your way back into that design, if you will, and then iterating it to ensure that that's proper. But one more comment to following up with Dawn. This came in on the chat. So to Dawn's earlier comment, what wind MRI is typically considered to act in the structural model, before the seismic PBD analysis is performed for seismic driven regions? And of
course, it depends upon the building that you're designing. Hospital buildings, I'm looking at a different MRI for my wind records than what I am for a regular office building, and so I have to meet the higher wind criteria that the code would require, the 3,000 year MRI for a hospital. I'll have to meet that criteria with input from the wind tunnel lab is really where we go. We go to the wind tunnel to get our wind time histories, just that they will develop for us, just like you would go get your seismic time histories from your geotech, working with your geotech to do that. You would do that with a wind tunnel company, and you'd work with them and get that, but it's based upon that same type of MRI that you would for your category of the building that you're doing. And they will develop that for you and your time histories with that. But, and maybe Melissa, I'll let Melissa handle this. but you also have to solve the other problems, the occupant comfort, the you know, those type of things. And those are looking at much different MRIs. And so I'll let Melissa handle that one because she knows that much better than me.
Yeah, so the consideration of the MRIs in the pre-standard in the PanCow document, we've actually paralleled those to the ASC 7, the new ASC 7s, so post '05 when we made the change to ultimate limit state. Now we are actually bringing in consideration at lower return periods, those which are more frequently occurring, of the order of 1 year, 10 year, 25 year, 50 year. And this goes back to the comment that I was making before about the fact that, your structure has a design life or a design space, not just a singular design point. And to kind of say why that's important is, I think the way that we traditionally think of our buildings is you turn on the wind and you get a load effect. You turn on the wind higher, you ratchet up the wind, you get a bigger load effect. You ratchet up the wind a little bit more, you get a bigger load effect, and you just keep getting bigger and bigger and bigger. But the reality is ever since we started to design very tall and slender structures, that ideology isn't true. And we have buildings that have dynamic sensitivities at particular wind speeds, at critical wind speeds. That means that what we call your vortex shedding peak, or the location where you get vortex induced vibration, can actually sit at your 10-year, your 25-year, your 50-year, for example. I've seen it as low as a 6-month return period in some instances for a very, very tall building. And what that means is that you ratchet up the wind speed and you actually are falling off the other side of the curve. So you start to ride up the curve and you come up a very, very steep curve that can be to like your velocity to the 3 or the 3.5. You hit a plateau at a certain velocity, and then you actually start to come down the other side. So in some instances, your load effect at 50 year can actually be lower than your load effect at 25 year. And what the performance-based approach does is it actually makes you be cognizant of this as being a potential risk in your design, and really being thoughtful about defining where that lives and exists, and how are you going to design to reduce the effect that actually has in your structure.
Yeah.
It's interesting that we can look at things like that so specifically when we take a performance approach. And as we were saying before, that may or may not really impact the cost of the structure. I mean, we're just looking at it probably more carefully with more purposeful attention to what, wind hazard we're using, what response we're getting, and things like that. So kind of along that line and leading to our work in ASC 7, I want to ask you this question from the chat. By approximately how many, what's the difference, let's say, in cost from the results from performance-based work versus the code-based analysis? It's probably different for every single one, but I don't know if there's anything that you can mention regarding that.
Well,
I'm going to ask Dawn to answer that question.
Yeah.
Thanks, Melissa. Well, I'm trying to figure out, are they talking about construction costs or design costs? Because those are totally different. Like you said, we've said multiple times now, the construction cost can actually be less using a performance-based design.
My guess would be it was following that thread when we were talking about construction costs versus design costs.
Yeah. So maybe Dawn, what we can do is we should talk maybe about the process that you kind of undertake. Typically, if we're designing a building, the first step would be you go to ASC 7, and we design with our prescriptive loads coming straight out of ASC 7. And then we modify our building, to ensure that we're performing against the wind loads that we've brought in prescriptively from ASC 7. Mm-hmm. Now, if you have a slightly special structure, maybe what you're going to do is you're going to say, I'm going to wind tunnel test this. Yeah. And I'm going to now, define my structural properties. I'm going to get a wind tunnel to carry out an assessment. And then the wind tunnel, what they return to you is a set of what we call equivalent static loads.
Mm-hmm.
So those equivalent static loads have taken into consideration all of the dynamic excitation that you could have in a building. And you define that in a static condition that you then bring back into your structure. And you then tweak your structure iteratively until you can still continue to meet those objectives that you've defined for yourself at the beginning of the process. Now, that's kind of the point where you would end. You might do a few iterations on that equivalent static load piece, but that's kind of the point where historically we would end.
Yep.
Now, what we're doing is we're actually going one step further. So we now are looking at taking, to Don's, what he was describing before, full-time histories from the wind tunnel. So we've tweaked our structure to the equivalent static load, and now we're taking it through a nonlinear assessment where we are actually allowing our structure to perform and behave in a dynamic excited time history. 3-hour duration is what we're using, 6 wind directions.
Yep.
We're allowing our structure to now see that natural fluctuation that exists in the wind and dynamically respond in time to those natural fluctuations. And so if the question is around the cost, you can, for design, you can kind of now see that, you take it through those same steps, but you now have an added step that extends, both the time and the need of analysis beyond your traditional endpoint.
There's always a lot of discussion about that, the effort involved and the benefit received. So thank you for that. That's helpful. Don, did you have something else to add to that?
My only comment would be that, the added cost in the design time, what I've seen on structures that I've actually designed using performance-based design, that I might get 4 times the amount of the added cost of design back in savings in the construction cost. Okay, so that's
a nice ratio.
Yeah, so it gives, like I said, the owner appreciates the fact that yes, you spent X dollars, but you got 3 or 4 times X back by spending that extra amount.
Okay, I want to get to the work that Melissa is leading within ASCE 7 for the next cycle. Just to give a little preview of what that is, how it ties back to what we're talking about relative to performance-based efforts, code-based efforts, and what that looks like going forward. So Melissa, why don't you share a little bit about that with us?
Okay, so this is in the performance-based wind design subcommittee to the wind committee that Dawn chairs for the ASC next version, 2022.
Yes.
2022.
Yeah.
So what we're doing in that committee is we're actually using performance-based design in 3 different types of standard sized buildings. So we are using a tall square building. And I'm going to speak, I live in Canada now, so I'm free to speak in SI units. 30 meter by 30 meter, 180 meters tall. And a second tall tower, which is now moving that same height building, but into a rectangular form, 30 meter by 45 by 180 meter. And a third building, which represents maybe more like a hospital structure, which is going to be only 50 meters tall and have dimensions of 80 meters by 30 meters. And what we're doing is we actually have 10 different structural engineering firms that have picked up steel mega brace structural design, a concrete core with fin walls, excuse me, concrete core with columns. So we have a number of different types of designs that we're now actually carrying out and taking right through this process. So right through the process of design by code, design by physical model wind tunnel tests. And we should do a shout out here for CPP because CPP has done all of the wind tunnel testing for this exercise. So defined all of and then we're designing with those equivalent static loads. And we're then taking that into performance-based design. And we're also looking at a new approach for reliability design. And this is really to take a look at some of the typical standard types of construction that we would use, and helping us to assess the value add by taking the design beyond that equivalent static load design. And we're hoping to publish some information from that come some point next year. We have MKA who's doing work on that. We have Thornton Tomasetti, we have HGA, we have NIST who's also doing some work, and EXP. It's really an amazing, I would say, collaborative effort in the structural engineering community that I think it's exciting that we've been able to bring all of these firms together to really, push the envelope.
Melissa, let me ask Melissa a question, if you can, Jennifer.
Oh, absolutely.
Yeah. Well, Jenna, and most people don't, they would automatically think your square building, your tall square building, would have the worst performance. Why did you choose the 1.5 to 1 ratio on your building also as a tall building?
Yes, so rectangular buildings also very much like to Vortex shed. 2 to 1, 1.5 to 1, they tend to have very interesting vortex shedding behavior. You tend to have peaks happening at your different return periods from the different critical velocities, from the directionality of the response. But the square building is also interesting because you have very similar modes. And modal coupling tends to be something that we see in tall buildings, and that modal coupling really can't be defined in any way other than taking it into the wind tunnel, and now really thinking about how you push it beyond. What I would say is that the buildings that we've selected in the climates that we selected them, Miami and New York, we are actually seeing loads in some instances, which is unsurprising, that are 1.5 to 2 times the loads that are coming out of ASC.
Yeah, that plan dimension, most people don't understand that those plan dimensions have a lot of impact upon the loads that you will actually see on your building. And as Melissa said, many of those loads are double of what you're going to get out of ASCE 7. So we need to be careful when we select those plan dimensions.
So you're working on that as a subgroup of Don's wind load subcommittee. What do you expect, practitioners will see in ASC 7 down the line, not in 22, but down the line, resulting from your work? What could you envision?
That's a good question. So certainly, come 2022, you will, we will have the ability to actually design with performance-based wind design in mind. Not to say that we can't do it now, but we have a place in the code that will, allow us to think about, look at it, and challenge ourselves in a different way in the performance-based world. How much of the exercise that we will take into the code, I think, isn't yet undefined, but certainly we do, and by exercise I mean these multiple organizations kind of stepping through the design changes. But we certainly will look to speak about that at the ASC conference, the next upcoming one. And we will certainly look to publish some of the outcomes from that.
Yeah.
And I think in the next code cycle we'll take a view as to what actually comes into the code from that exercise.
Well, and
Yeah,
let me add to Melissa on there. The one thing that's really important that most people, why are we doing all this work? Why is Melissa leading this team of doing all of these work, and
yes,
why did these structural engineering firms agree to it? The only way that we can get all of our the pre-standard and actually get it to be a standard is if we understand the reliability we're going to get out of the designs that we're doing. And so that we can meet the reliability index that is in ASCE 7. Seismic has their, using performance-based design, they give a certain reliability index in chapter 1 of ASCE 7. And we need to demonstrate through these studies that we're doing that we're going to get the same or better reliability from using the pre-standard that what's in ASCE 7. And as we do that, then we'll be able to develop take the pre-standard to a standard that will be able to be used by the design community independently to do that. Like Melissa said, you can do it now, and the design as long as your building official or authority having jurisdiction agrees to that, you can do it now.
Yeah.
We just want to establish that we're getting the same reliabilities so that that standard will be met and it can be really developed into a standard.
I can't even believe how fast this went. It's already 20 past the hour and I have like maybe 7 more questions I want to ask you guys. So, all right, I'm going to try to pull back a little bit from the wind topic and maybe just in our effort to maybe wrap this up towards the half past, start thinking about performance-based kind of in general, the bigger concept and bigger topic of that. We have mentioned seismic has been on this trajectory for a couple of decades, 30 years or so now, and wind is just getting started. We have a little bit going on in fire. What are your thoughts around, where else are we maybe ready to take that first step, or what are the challenges around it aside from research and the work that Melissa's doing maybe to support further development of documents around performance-based design, more generally accepted or used? Anybody want to take that one?
So my first comment would be that I would also challenge us to think that maybe performance-based design is the step in the right direction to really, the resilience-based design. And resilience-based design really means that we're thinking about, holistically all of the buildings that we are designing from multiple different angles, multiple different hazards that could impinge or affect the performance of these buildings, and really starting to challenge ourselves to be more conscious of the environments in which we build and the impact that that we are having on the built environment, and the fact that we are building a built environment for us as people to live, reside, and work in. And we all want to be in a building that has had some of this deep thinking. And so I think that, for me, it's exciting that we're seeing this happen now, because it means that, collectively, as an industry, we are on a journey to actually creating better cities.
Mm-hmm.
Yep.
Mm-hmm.
And well, and to add on to that, and I agree 100%, we need that. It's amazing that the performance-based design is really happening at the same time that the resilience discussion is occurring across the country, because they really do go hand in hand. Mm-hmm. And I look at Japan, and do I agree with all of the concepts that the Japanese have done in performance-based seismic design and how they design their buildings? No, I do not. But I do look at how they have integrated that with resilience and have can't think of the right term, but they've used it to sell their buildings as, here is this more resilient building because we've done performance-based design. And so you want to live here. You want to occupy this building because we've done the extra amount of work to do that. Those are the concepts that we need to look at, and that, as Melissa said, you want your building, you want to be able to walk into your building after the after the event,
Mhm.
and it still be there, and you're still able to either work there or live there or do something. Doesn't mean all the lights are going to be on and there isn't some paint or some drywall that you got to fix, or some broken glass you got to repair.
Yeah.
Those things might all be there, but your building's still there and you're able to still occupy. And that's what performance-based design will help us to understand and about our buildings and help us to design to those, like I said, integral with the discussion on resilience that we need to, as communities, we need to have.
Well, I listening to you both talk about that last piece, which again, we could go another hour on this piece, but I just wanted to kind of put that out there, and we talk about our profession and structural engineers as designers and where can we contribute to these types of value propositions to society. This is an obvious one to me once we start talking about performance of buildings, really looking at human-centered design like you were talking about, Melissa. How can we add value and bring that to our owners and then an extension, to the rest of our society that way. So I think that's a fabulous idea. Again, we could go on quite a little bit about that. I know we do have talked about in the past that performance-based design can be used to address some of those other hazards that are beyond code, such as future conditions or resiliency or even sustainability type goals, kind of are all in there. We have about 5 minutes left. So I want to just give you both, kind of your last opportunity to put anything out there, closing thoughts. It's hard to kind of wrap up this kind of discussion with a few minutes here right at the end. But I wanted to give you both that opportunity to do that before we close up. I'm going to have some announcements at the end, and then we'll end up here in about a few minutes.
Okay.
So go ahead.
Go ahead, Don. Sorry.
Oh, that's okay. I guess my summary would be here a little bit. I'm doing a project in my office currently. It's a quote unquote research project, I guess is what you would describe it. It's for the Applied Technology Council, where I'm designing some buildings for the code requirements in the 1980s.
Yeah.
And then comparing them to redesigning them to the current code requirements and comparing to them on what the effects are going to have. And the phase 2 of this project will be to run some nonlinear analysis of them to see how they're going to perform in different events. But they're mostly on the East Coast because we wanted to make them wind controlled buildings. They're not tall buildings. They're I think the tallest building is a 12-story building. Not that tall of buildings, but so the wind really controlled them. And then we looked at it. But I've had junior, I'm not doing all those designs. I'm having design engineers in my office do them, or project engineers in my office do those designs. And one of the gentlemen came up to me here recently, and I've shared this quote with Jennifer. He said to me, Don, I do not know how you guys designed buildings in the 80s, okay? Because there's no prescriptive code requirements in the 80s for all of the conditions that you needed to look at. There were just a few drift requirements or whatever, not all of the step-by-step that the code has worked into. And I hadn't thought about it. Believe me, I've been designing since the 80s. So I have the gray hair to prove it, that I've been designing since the 80s. And I didn't think about it back then, but we're heading back to that, to where we don't have to have the code tell us every step by step. We're going back to the engineering principles that used to be in the 80s that we used. Even our code required us in the 80s to use engineering principles in our design and to satisfy the needs for the owners on that. And that's really what performance-based design is really taking us back to. And that's what I appreciate, going back to where we're using the principles that we learned. We're all smart enough to think about those principles that we learned in college and use them. And that's what performance-based design is taking us back to.
Yeah. Thanks, Dawn.
Yep.
And Dawn, I guess I would just maybe echo that and just say that what I heard in what you were saying is opportunity.
Yep.
You know, opportunity for us to actually challenge ourselves in ways that we know we can, and with an outcome that we're actually going to be designing a better built environment if we do go forth in that direction. And I think that we have computing power available to us at an unprecedented, amount to that which we had 10 years ago, and to that which we had 20 years ago. And so there's no reason why we shouldn't be, trying to take our designs through some of those next steps, because it's not time. It's really computing power and thoughtfulness, and challenging ourselves to actually do things in the right way to move forward into this new world of performance-based design, new world for wind, less of a new world for seismic.
Yeah, yeah. Well, that is a very nice, very accurate, very good summary. SEI has, along with NCSEA and CASE, signed onto the vision where we are trying to advance performance-based design within our profession. And so it's just put one foot in front of the other and keep doing the good work that you all are doing. So I just want to make one announcement before we close off. Starting off in January, actually, SEI is going to launch a new standard series where I'll be hosting 6 sessions. So every other month we'll do on a discussion like this with some committee chairs about their new standards that are coming out. The first one in January will be on ASE 48. So that's an ETS standard, electrical transmission structure standard. And so it's a kind of an idea to get those documents out there to understand what is in them and why we are advancing in those different niche kind of markets. So look on SEI webpage for that and register. And then finally, as we wrap up, I just want to very much thank my guests today. Thank you, Dawn. Thank you, Melissa, for coming. This was super fun. It went by really fast like these things always do, but we will, of course, keep on the discussion. I'm sure we'll be talking about this in the future. I want to thank all the attendees for coming. Thank you for supporting SEI in this way. I also want to thank my team. There's a lot that happens behind the scenes and getting it all organized, so thank you so much for that. And also do have a wonderful holiday season. This has been a tough year for many, so enjoy the holidays as we close it out. And this concludes today's session. Thank you very much.
Thank you.
Thank you.